Hello everyone, we are going to talk about exposure process with liner type equipment. This is the basic, simple, inferior type of exposure, and we use it to show you the basic principle to run exposure process. This is the most simple exposure. This is exposure, and we got to connect to the exhaust because the UV light produce the ozone gas. It's a poison gas. It can hurt the human body. Some equipment engineer staying to fix the exposure and for a long time and cut off the exhaust without exhaust. Breathe too much ozone can make you dizzy, then injured human body. So it must be having exhaust. Keep it 24 hours. And this is the quartz lamp. The brand lamp is very bright. Can hurt your eyes too. Engineer service with the liner, especially the lighthouse part of the equipment must be turn off the light. Two reasons. One, the light of the quartz lamp are very bright. It can hurt your eye, make your eye injured, and maybe blind for 1 or 2 hours, or make your eye disfocusing at anything else. So it can injure your eyes. Please wear protect glass, put on your eye, and the best way is to turn off the light. Second, the quartz lamp body is very high pressure, a high temperature. The high temperature will get you injured. Hundreds temperature outside the body, inner the body of the lamp, 1000 temperature, 1000 degree centigrade. We talked about it before. About the quartz lamp character, we talked about it before. And this is the eclipse reflector. We talked about it before. It make the beam from the lamp to project forward to the next optics parts. And this we call reflector. It can reflect the beam from the eclipse reflector to next optics. The reflector is adjustable for the uniformity. So if you have uniformity issue, can adjust it. And this reflector mirror usually coating a IR filter film to filter the IR and some particular wavelengths beam we don't use it. And also we use the nitrogen gas as a cooling gas into a light house to cool down, especially these parts, high temperature parts. And next, the light beam be reflected by the reflector to the next optics path. This path we call it uniformity improver. Uniformity improver has a special structure. The purpose is to spread light beam evenly to let the uniformity better. And it also can be adjustable. After the light beam through the uniformity improver, go to the next optics. We call it parallel lens. Parallel lens make the light beam to be parallel light beam direction. Also can be adjustable for uniformity. Finally, the reflector reflect the parallel light beam and to do the exposure process to our wafer. The reflector also can be adjustable for the uniformity. So, a lighthouse has many optics parts to be adjustable for our uniformity. Then we detect the intensity and we got the intensity, and we can use it for exposure process with a good uniformity. The process engineer choosing lamp depending on some parameters of the lamp. First of all, we choose the wavelength. From the old time, I line, G line, H line, as we talked about before to now. The DUV light. We choose the wavelength just depending on the photoresist design and the IC design. and we choose the intensity. Is intensity too strong? Sometimes it's difficult to control by the time, and too weak. It costs a lot of time to slow down the throughput. So we choose a suitable intensity value lamp to execute our process with high throughput and easy to control. And finally, the filter capability. The lamp can filter some period of the wavelength light to avoid non-use wavelengths to affect our process. Even the light beam direction can filter by some lamp design. For example, you can choose the ozone free. Each side special field to let the ozone free. Next, the intensity, the unit is milliwatt per square centimeter. Now use the meter to know the intensity of the light beam, and we just tune the time, how many seconds we can get the energy millijoule per square centimeter. This is the energy process engineer want, and according to the photoresist design, how much energy the photoresist required according to a design. Exposure type for process engineer choose to use one kind generally speaking, the name contact mode. This is the wafer chuck. This is the radical mask, and this is our wafer. We use a chuck to push the wafer to contact to the mask. This is the basic and very old type exposure type, and it to make the substrate and the mask no distance, and we can get the most good, the best resolution from it. But first of all, we must to confirm the mask will not be polluted by the wafer photoresist. So this way we got the best resolution, but it get pollution from the photoresist of the wafer to get the mask dirty. Avoiding mask pollution, we used called proximity contact. The chuck push the wafer to contact to the mask just a little force, and then going down a little bit to have a gap, approximately gap, a gap set by the process engineer. This way the mask get very less photoresist pollution, but the resolution is a little bit lower. Now the third type is called soft contact. We don't want the photoresist on the surface of the wafer be pollution to the mask. So while we want to execute exposure process, the chuck approaching to the mask and the then chuck vacuum off and purge the nitrogen gas to push the wafer to very soft, even no force to contact to the mask. This kind of contact, call it a soft contact, one almost no pollution. Two, we got a good resolution. And this is the advanced soft contact. We call it gas vacuum contact. The chuck purge the nitrogen to push the wafer as the third type. But the nitrogen not too strong. By vacuum back to chuck. Chuck has a vacuum force to suck the nitrogen back, and the nitrogen will be very weak, but still continue to blow, and the nitrogen be sucked by the vacuum. It keep the substrate no move, and we get a good resolution and no photoresist pollution. And this gap is so small, almost no gap. Some factory want to get the best resolution, use the contact mode, and it clean the mask very often. Keep the mask in a clean condition, then he will get the best resolution. Of course, the liner type equipment is a very old and inferior equipment for exposure process, but still the after end fab factory still using them, or some labor still using them. The laboratory just use the exposure to test its own advantage experiment. So this kind of machine still using now. Okay, let's all see you next time.